You're welcome to FUNNYMATH page. In today's lesson, we continue with our topic on enlargement and similarities. So this is going to be the second part. So we talk about similarities. In our previous video, we talk about enlargement. If you have not watched the video, you can go, and watch that video. Now let's continue. When shapes are similar, then it means they look the same. Oh yeah. So when the shapes are the same, then it means they are similar. So as you can see, this is square ABCD. It is similar to square PQRS because they have the same shape. Now, the moment we get similar shapes like this, we can make out some deductions. And one of them is about their angles. Now, similar shapes have their corresponding angles to be the same. So the angle at, let's say, A is the same as the angle at the point B. So the corresponding angles are the same. When you take that of, let's say, B, the angle at B is the same as the angle at Q. These two angles also correspond. The two remaining angles. Now, let's talk about their sides. When shapes are similar, then we can say that the ratio of their corresponding sides are equal. This property is very, very important that we are going to use to solve a lot of questions. So let's get that property here. So this is what we are saying, the ratio of their corresponding sides. Now let's see, the side AB corresponds to the side PQ. So what we are saying is that the ratio of their corresponding side, that is, AB to that of PQ is equal to, we can take, AD to that of PS. So you can say AD that of PS. And that is not all. You can also talk about DC to that of SR. So you have DC to that of SR. And the last one is going to be, CD or BC to that of RQ. So let me get it. CB to that of, ratios can be written as fractions. So that means we can rewrite them as fractions as this. So we have AB out of the side PQ, and it is equal to, the side AD out of the side PS, which is also equal to DC out of the side SR. And finally, it is also equal to, CB or BC, they are the same, out of RQ. So this one we can make from these, two shapes here. So what you should know is that when shapes are the same or they are similar, then the ratio of their corresponding sides are equal. We can use this idea to solve some questions. Triangle ADE is an enlargement of ABC. Find the value of x. So ADE is the bigger triangle and the smaller one is ABC. So what you have to know is that we have enlarged this small triangle ABC to get triangle ADE. So that means the new shape is similar to the previous one. So we have to redraw the diagrams for the shapes so that we can see the corresponding sides clearly. So now, let me do that one here. So when you redraw the shape, this is what we're going to get. So the triangle ABC, that's the small one, and the triangle ADE, that's the bigger one. So these are the two triangles. Now let's get the magnitudes. From the question, AB has been given to be 6 centimeters. So here is going to be 6 centimeters. Now, BD is 6 centimeters. But you should know that AB plus BD will give us AD. So this is what I want to say. AB plus BD will give us the side AD. So when we add these two sides, we are going to get, AD. So that's going to be 6 plus 6, and that's going to be AD. So 12 centimeters is equal to the side AD, or AD is equal to 12 centimeters. We also have BC to be X, that is here, and that of DE, or ED, to be 24 centimeters. So this side is going to be 24 centimeters. Now the question is, how do we get X? We have to use the ratio of corresponding sides. Now we can see clearly the corresponding sides that can be used here. Now AB corresponds to AD, so we can say that the ratio of AB to that of AD is equal to, since we want to find the value of x, we have to use this side, that is BC to that of, BC corresponds to AD. So to that of AD. So this is how we can set up our equivalent ratios. So the next thing is to do substitutions. AB is 6 centimeters to that of AD. AD is 12 centimeters. And that is equal to BC. That is what we are looking for. And that is X. To that of ED. ED is 24 centimeters. So we can rewrite the ratios as, common fractions. So we get out of 12 centimeters. And that is equal to X out of 24 centimeters. So at this point, we can just do cross multiplication. So X multiplies 12. So we have 12 multiplying X. And that is equal to, 6 multiplying 24. We can also decide to simplify 6 and 12 before you do the cross multiplication. In each case, we are going to get the same answer. So I have to divide here by 12, here 2 by 12. When you do the cancellation, 12 goes into itself 1, goes here 1 time. 12 can go into 24 2 times. So 12 here 1 goes into 24 2 times. So this implies that X is equal to, 6 by 2, which is equal to 12 centimeters. So that's the value of X. In triangle ABC, that is this triangle ABC, AB is 5 centimeters. That is from this point to this point, that is 5 centimeters. BC is 8 centimeters. We have it here. And AC is equal to 6 centimeters. That is from this point to this point. We have that one too here. Point P lies on AB such that AP is equal to 2 centimeters. That's the point P. It lies on AB, and that is true. And AP is 2 centimeters. We have that one too here. The line through P, parallel to BC, intersects AC at Q. That is true. The line through P, parallel to BC, intersects AC at Q. That is very, very true. That means they meet at Q. We have to calculate PQ, that is I. And where is PQ? I mean this line. We want the magnitude of this line, PQ. And after that, you have to find QC, that is this point, QC. We don't know that one too. So how do we, begin the solution? Now this is what you're supposed to know. Anytime you get 2-in-1 shapes like this, we have 2 triangles in, this particular triangle, APQ, that of ABC. So they have been merged. So anytime you get something like this, try and redraw, the shapes separately so that you can see the corresponding sides perfectly, so that you can use, the property to find what you are looking for. So I'm going to redraw them separately so that we can see clearly the corresponding sides. So these are the 2 triangles. So let's take this one to be the small one, that is APQ. So here's going to be A, here is P, and this point is Q. Now we can get a bigger one, A, B, C. So here's going to be, A, here will be B, and that of here is going to be C. So with the magnitudes, PQ is what we are looking for. This is what we are looking for, PQ. But we know AP to be 2 centimeters. So AP is 2 centimeters. We also know, AB to be 5 centimeters. So here is going to be 5 centimeters. We know BC to be 8 centimeters. So here is 8 centimeters. And that of AC to be, 6 centimeters. For AQ, we don't know. So that's how we can redraw the shape. Now let's get to the first point, that is PQ. How do we do that? You know that the ratio of the corresponding sides are equal. Now we can see that AP and that of AB, they correspond to each other. So we can form a ratio with that. So that's going to be the side AP to that of the side AB. And it is equal to, you can also see that PQ and that of BC, they correspond to each other. So it's equal to, PQ, that of the side BC. So this is the equivalent ratio that we can, form from these similar shapes. Now let's move on. AP is given the question to be 2 centimeters. We have 2 centimeters here to AB. and AB is also 5 centimeters. So here is going to be 5 centimeters. So it's equal to, PQ. PQ is what we are looking for. So we just have to rewrite the same thing, PQ to BC. BC is 8 centimeters. So we have that one here. We know that ratios can be written as, fractions. We are going to get 2 centimeters out of 5 centimeters, and that is equal to PQ out of 8 centimeters. So that's what we have. Now at this point, we can do cross multiplication. So something like this, 8 can multiply 2, and 5 can also multiply PQ. We have 5 multiplying PQ, and that is equal to 2 multiplying 8. So we divide here by 5, here 2 by 5. So that means 5 can just cancel out this 5. So we have PQ, that's what we are looking for. It's equal to 16 out of 5. That is 2 times 8 is 16. So when you do the division, you're going to get 3.2 centimeters. You have 3.2 centimeters here. So that means PQ is 3.2 centimeters. So let's get the second one here. That is going to be II. So the second one is talking about, QC. How do we find the side QC? Now we can see that QC forms part of the side AC, and AC is already 6 centimeters, which has been given already in the question. Now, if we want to find QC, then we have to get AQ. When we get AQ, we just have to subtract from 6 centimeters, and the remaining is going to be QC. So the question is, how do we find AQ? So this is AQ here. You know that AQ corresponds to, AC. So now that we know this, we can just say that the side AQ to the side AC, they are corresponding, and it is equal to, we can use this one, the one that we know already, that is AP to AB. So we have AP to that of AB. So that's how we can set up our equivalent ratios here. Now let's do the substitutions. Now we can do the substitutions here. AQ is unknown, so we are just going to write the same thing. So we have AQ unknown, but we know AC to be 6 centimeters. So we have 6 centimeters here, and that is equal to AP. AP is 2 centimeters. So we have 2 centimeters. That of AB, that is 5 centimeters. Now we just have to rewrite, them in fractions. It's going to be AQ out of 6 centimeters, and that is equal to 2 centimeters out of 5 centimeters. Now we just do cross multiplication so that AQ multiplies 5. So we have AQ multiplying 5 centimeters, and that is equal to 6 multiplying 2. So you have to divide here by 5, here 2 by 5. So this 5 will just erase this one. So you have AQ, and that is equal to 12 divided by 5. You're going to get 2.4 centimeters. AQ is 2.4 centimeters. So like I said, we are not done. We are looking for, QC, which is this side. We have to subtract AQ from 6 centimeters. So let's do that here. So this implies that QC is equal to 6 centimeters minus 2.4 centimeters. So when you do the subtraction, you're going to get QC to be equal to 3.6 centimeters. So that is how we can find QC. So let's get this interesting question. If ABCD, that is this shape, that's a trapezium, and PQRS, this one too, are similar, you have to find the value of B. So that is B. Now how do we get that? So this time around, the shapes have been drawn separately, so we can see the corresponding sides well. So we don't need to, redraw the diagrams. They are just clear. Now, we have so many sides or corresponding sides to help us find the value of B. So I want to use, BC to that of SR. We can also choose different sides, and we have to arrive at the same answer. So I can say that, BC to that of, SR. And since I want to find the value of B, I have to use DC and that of KR. So it corresponds to, the ratio of DC to that of KR. So now, if you have to do the substitutions, BC is 12 centimeters, so you have 12 centimeters here. To that of SR is 20, so you have 20 centimeters here. And that is equal to DC. DC is 18 centimeters. To that of QR, and that is B. That's what we are looking for. Now we can rewrite the ratios as, fractions. So you have 12 centimeters out of 20 centimeters. And that is equal to 18 centimeters out of B. So at this point, you have to do cross multiplications. Or we can simplify this one. So let's simplify before we even do the cross multiplications. So 4 can go into 12, 3 times. It goes into 25 times. So that's going to give me 3 out of, 5 equal to 18 out of B. So at this point, I can do the cross multiplication. So now 3 will multiply B, that's going to be 3B, and 5 also multiply 18, which can be simplified as this. We divide here by 3, here 2 by 3. So the 3 will just cancel this one. We are left with B. So B is equal to 3 can go into 18 6 times. So 3 here 1. It goes into 18 6 times. So you're going to get 5 times 6, which is equal to 30 centimeters. So that is how we can find the value of B. You can use different size to find the value of B. Thank you for watching.